All right, so we're now going to talk about a technique for animating leaves other than just using the regular Onyx wind animation. And so to demonstrate that, what I have open is a scene that has a bunch of eucalyptus trees in it. And these are all from Onyx. And so you can see and hear which of the Onyx presets I exported. So pretty much all of the eucalyptus presets. So if we jump over to Onyx for a second, let me just load it. All right. And then in here, if you go to the broadleaf library, and I'm just going to hit E, you'll see that there are in here a bunch of eucalyptus trees. And they're actually all really cool. And so there are a few of them, which is awesome, which means that for creating a eucalyptus forest right off the bat, we have a pretty nice variety of different types of eucalyptus trees. And so each one of these, one at a time, I just, loaded them into Onyx. And then pretty much with just the default settings, exported them as OBJs. And so static, non-animated. And so for this one, if I go in and, turn on shading and the sunlight and the shadow, we can see what it looks like. And if I choose to go to save model as OBJ and hit count, then inside here, we can see that it's not rendering the twigs, or the twigs are off by default. And so that's just because in the end, they're really, really small. Under plates, if I put the number of P objects to 1 and increase the resolution, then my polygon count, you can see, jumps up to 272,000 polys, which is fine, and pretty much good to go. So as far as whether or not I export the twigs or not is just a matter of how close I think I'm going to be to this tree. So because if I have it displayed the way it is right now, and let's just turn off the shadow and turn off the sun, if I turn the twigs on or have them off, I don't really see a difference, and that's because the twigs with the eucalyptus tree are extremely short. And so if I go over to the branch, I can see that the stem length is 35 millimeters. I can see in here that the twig length is 9 centimeters, but they're just not that noticeable from a distance. So I think I had the twigs off when I exported them. But basically, just export them one at a time. I didn't really change any of the settings. That's one of the nice things about Onyx, is that a lot of these presets are kind of good to go. So one at a time, I loaded each one of those eucalyptus trees in Onyx, and then I exported them. And so once we get over to Maya, then in here, what I've got is a couple things. One is I have all of these eucalyptus trees. So you can see this one is 34,000 polys, and if I open it up, I can see that I don't have the twigs. Let's just drag that a little bit. I don't have the twigs. So you can see trunk, bough, branch 1, 2, 3, and the leaf, but no twigs or stems. And if I go to this guy, same thing. I didn't export the twigs or the stems. So these are pretty much all just default eucalyptus trees from Onyx. And then what I did is, based on what we covered thoroughly in the second DVD where I talk about grass and the instancer, I instance copied some of these trees onto particles. And so if I go in here, we can see that if I rewind to frame 1, I have initial state saved on these. But this plane that's there, that's highlighted, is emitting particles. And then those particles via the instancer, so I can see I have an instancer node inside here, is instancing those trees onto the particles. And then on my particle node, I'm randomizing the rotation and randomizing the scale to basically get that look. So no need to get into the details of that since that's covered so thoroughly in that other DVD, but that's what's going on. So I just created a simple plane that's in the camera view to emit it. And then as far as saving initial state on the particles, that's obviously so that they're all there at frame 1. And I also have a particle disk cache inside here, which means that I can click in the time slider and things will update. So the scene right now has about 39 million polygons in it via the instancer. Although if I scrub to frame 1, yeah, it's about 39 million. and you saw what it looks like rendered. So as far as the shaders go, this is all physical sun and sky with an MIA photographic exposure node. And then for the MIA materials, I only have two shaders in the scene. One which is the bark shader for the eucalyptus trees, and one is the leaf shader for the eucalyptus trees. So we can talk more about shading and all that stuff later. For now, I just want to get to the animation portion of what's going on in here. So, but we will see that if I do open up the Hypershade, we can see that it's very, very simple inside here, meaning that I have this shader for the tree bark, and I have this shader for the tree leaves. And so you can see I have this leaf that's just being repeated on a 3x3, although I'm not actually changing it very much. It's just I already had the UVs in a 3x3 tile, and there's my shader. And it's a double-sided shader, so I can see with my MIA, I have an MIB two-sided, so I have the front color of the leaf and the back color of the leaf. Also, my leaf texture, you can see the leaf is relatively round, although I did, via the preset, allow the leaves, let me just switch to a different camera and zoom in on this, allow the leaves to be non-square, meaning that the leaves inside here are just the default as Onyx created them, meaning that just like a eucalyptus tree, we've got very, very long, thin leaves. And so that allows me to use a texture that's not long and thin, but still get that eucalyptus tree type of look. So sometimes having your leaves be non-square just makes your life a little easier if you don't have the right texture sitting around. So as far as the animation portion of what's going on in here with the animation of the tree leaves, what I'm going to do is I'm going to actually go and let's turn off the instancer so that all we're looking at in here now is just the actual trees that I imported. And so if I now rewind and hit play, so yeah, it's still not super fast. I'm going to get things just so that they are nice and quick. And so basically what I need to do is let me just delete a couple things in the scene that we don't need. So I'm just going to get rid of that plane back there and get rid of that particle object and get rid of my instancer node. And then in here, let's say which tree will we keep? Let's say we'll keep that tree. I'm just going to hide some of these trees. So we're now just down to one tree. All right, so now things are a little bit faster. And now let me switch to another camera. And hit play. And so what you should be able to see is there's some movement in these leaves. And so that's the thing that we're going to talk about. So if I look really close on it, it looks a little funny because again, this isn't for near ground leaf behavior. And so what this is something that for a tree that's really far away, it actually looks just fine and makes it look like the leaves are blowing in the wind. So how is this done? Well, this is done via some dynamics and specifically using lattices. So you can see I have a whole bunch of lattices inside here. And so I'm going to need to really kind of just create this from scratch. So I'm going to go and delete all of the dynamics nodes that are inside here. So they're gone. And then in my scene under dynamics, let me just make sure I've got no cache, meaning that Maya's just kind of normal. So no animation, no cache, just a tree. And on this tree, if I select it, there's no inputs on any of these branches or leaves. So it's just a piece of geometry with a shader on it. So in order to animate the leaves, what I chose to do, and what I've done a few times just because it's simple, is instead of animating the leaves manually, which you don't want to do, and instead of exporting an Onyx OBJ sequence, which takes a bit of time, I can go in and take this tree, and for the purposes of really simplifying what we're looking at inside here, Let me just delete everything we don't need. So all we have is a ground plane, a sunlight, and this tree. All right. Well, for the tree, what I can do is I can go in and choose to select something like the leaves or the leaves and the branches and put a lattice on them. And this is useful just in general when you want to change the overall shape of a tree. So meaning if I select the entire tree and I go to Animation, Create Deformers, and I create a lattice. And in the options, I'll hit Reset. So everything's at the default. I will get a lattice. And so lattices are of course awesome. If I right click and go to lattice points, I can select some of these lattice points and I can move them. And this allows me to obviously change the look of my tree. So I could choose to, rotate that a little bit and move it to the right a little bit if this tree just needs to suit my scene a little bit better. So that's using lattices as a modeling tool. One thing to point out with lattices, however, is that if I move them, you'll see that only what's inside these quadrants gets affected. If you want to smooth out the look of the lattice, you can select it and go to the attribute editor. And then in the attribute editor, you will see that you have a node called FFD1 for freeform deformation. And there's an attribute called local, which is on. If I turn that off and I go to my lattice and grab lattice points, now you'll see that when I move, it's actually affecting a lot further into the lattice instead of just based on quadrants. So you get a much smoother, curvier deformation. And sometimes that's preferable. And so it just allows me to get something that doesn't look, fragmented, where we're seeing kind of like a facet in the geometry as a result of the lattice. And so it just gives something that's a lot smoother of a look. So if I take that lattice and delete it, we just get back to our tree. So that's what lattices are. And so it's just that FFT attribute is useful. So if I wanted to be able to take these leaves and maybe the branches and just add a little bit of subtle animation to them, I can do that by using a lattice and animating the lattice points. And so I'm going to go inside here and take, let's say, in this case, I could probably get away with doing, just the leaves and not the branches. So I'll select the leaves. I'm going to create a lattice. So it just creates it just around the leaves. And then in the options for the lattice, you can choose the number of divisions it has. So right now it's at 2, 5, and 2. So if I put it to 5, 5, 5, it just gives you a lot more control, right? So if I go and right click and grab some lattice points, it's just giving us a little bit more fine-tuned control inside here. Well, the idea of where we're going with this is we're going to take this lattice and we're going to make it dynamic so that it can react to fields, specifically a turbulence field. And so in order to do that, we're going to use something called soft bodies in Maya. So there's a lot of stuff that's useful to know about soft bodies. We're just going to take a very basic approach. So it's kind of like a step-by-step thing. So if I have a lattice that's already affecting my geometry, as we can see, I can move the whole lattice, or I can just go and grab individual lattice points and move those. We can see that if I go and grab the lattice and I go to dynamics mode and I go to soft/rigid bodies, there's an option in here called create soft body. And what that'll do is for geometry or a lattice, it'll replace each vertex or lattice point with a particle. And then that particle can be affected by fields. So if I go to the options and I hit reset, the default options will do exactly what I just said. So it'll put a particle at each lattice point. It'll just make it soft, and then you could apply something like a turbulence field. But the problem if we do it that way is that these particles or these particles that are the lattice points will not remember their original shape. So basically this tree will just slowly get ripped apart over time. So what's important for the soft body is that we go and choose one of these options: duplicate make copy soft or duplicate make original soft. Now in this case I would say duplicate make original soft, meaning the lattice that's selected is the original, and that's what's affecting my geometry. So that's the one that needs to be given particles. So duplicate, make original soft. And the reason we're making a duplicate is because the copy becomes a way for the lattice to remember its original shape. So meaning you have the original and you have a copy. The original has particles, and the copy is the state of the lattice when it was undeformed or unaffected by particles. That's called a goal in Maya. And so I'm going to say make non-soft a goal with a weight of 0.1, and then I can choose to hide the non-soft object because I don't need to see it. So duplicate, make original soft, hide non-soft object, make non-soft a goal. So if I put the weight of 1, the soft lattice would be fully locked on to the original lattice, and fields would have no effect. And if I put the weight to 0, then it would not pay attention to its goal, and it would just get ripped apart by fields. So basically you can choose on the whole, for the whole lattice, a weight value. And then for more control, every single particle that gets created at each lattice point has its own goal weight, which is called goal pp. And so I could choose to put this at 1 and just use goal pp instead, but for simplicity we'll just use this goal value. So if I hit create, what you should see in the outliner now is we have our original lattice and a copy of the lattice, which you can see is hidden. And the original lattice, if I open it up in the outliner, so just make sure you have display shapes on, you'll see now has a particle object. There's now a particle at every single lattice point. And so what that literally means is I can now grab this particle object, and then under dynamics, go to fields, and I'll create a turbulence field. And I'll just use the default options in here, create. And now I'll rewind, and I'll hit play. And let me also go to the options in here and play every frame. Okay, cool. So now that's playing, but I'm not really seeing much of an effect. So I'm going to go to my turbulence field. Has a lot of attributes, and the more you know about this stuff, the better, but you don't have to know a lot. Your turbulence field has a magnitude, which is its strength, and it has attenuation, which is fall off. I'm going to turn off the fall off and put the magnitude really high. And rewind and hit play. And now we're starting to see something moving in the geometry, but let's try putting magnitude to 500. Now you're going to start to see a little bit of movement. Magnitude 5,000. Okay, so there you go. You can see that this turbulence field is now affecting the particles, and the particles are affecting the lattice points. And now we're able to get some behavior inside here. So if I were to go to this particle object, that is the lattice points, you'll see that of all the attributes it has, there's an attribute that's called goal weight. So if I hit play and I put the goal weight to 1, it gets fully locked onto its original shape. It's seeing the copy, the one that's hidden, as kind of like almost like a blend shape target, but it's not blend shape, it's called goal weights. So if I put the goal weight to 0, this thing is going to get completely ripped apart, as you can see inside here. So the goal weight value just allows you to balance between how much it's staying locked onto its original shape and how much it's able to get affected by fields. So with something like this turbulence field, if I hit play, we now want to basically have control over the behavior or nature of the turbulence field, which you're going to do primarily via frequency and phase. So if I lower the frequency to 0.1, you're going to see that you're going to get a very different behavior than having a frequency of, let's say, 5, where you're going to get a lot of sort of tinier shifts inside there. It's a little bit more jittery. So it's literally the frequency of the pattern being used by the turbulence. So for something like this, I might want a lower frequency in there. But then for the turbulence, turbulence by default, this is kind of going to be a strange concept, but turbulence is a static field. It's not actually moving. If you imagine like a 3D matrix of arrows, all of those arrows are pointing in different directions, but the direction they're pointing in does not change. So what's creating the movement in our particles right now is the fact that the goal weight on them makes them move with the particle field, but then also try to return like a rubber band back to its original shape. And so it's creating like a bouncy movement. But for turbulence fields to look more natural, you really do want the turbulence field to actually move and change over time. And the way you do that with a turbulence field is to animate the phase attributes. So if I want my turbulence to move along the x-axis, I would animate the phase x. So I'm going to go in here on phase, and the best way to do it is Control right click, go to expressions. I'm going to say turbulence field 1.phase x, middle mouse button, drag it down here, equals, let's say, time. Or I could say equals frame. So that just means that as time goes by or as frames go by, the phase increases in value. So let's say it equals time times 10. That's just going to make it move a little bit faster. So at frame 24, at 24 frames per second, 24 divided by 24 is 1. So at frame 24, this would have a value of 1. So hit create, and now my phase is animated. So then inside here, I'm going to go and lower this magnitude down so it's not quite so high, so that I start to get something that feels like there's some kind of movement inside my leaves. And so you can see that from a distance it's going to generally feel like there's some kind of wind in here. So I could obviously also go to the particle object and play with the goal weight. Now the goal weight, if I put it to a lower value, they're going to be affected a lot more by that turbulence field, as you can see. And so I could have a lower goal weight and also go to the turbulence field and lower its magnitude. So it's kind of a balancing act between the magnitude that you have on your turbulence field and the goal weight that you have on your particles. So this is something that is just a useful way to get the look of movement in your leaves. That's not necessarily totally accurate. So if we go up close, it's going to kind of look like these leaves are underwater or something, which kind of looks cool, but that's not necessarily the effect we're going for. But if we zoom out and look at it from a distance, your eye, if this is just a background tree, will just read that there's movement in the leaves. And that's what you're going for with this. So I can go and increase the magnitude on the turbulence field a little bit, increase the frequency so it changes direction a little bit more often. I could change the phase just so that the turbulence is moving through space faster. A few different controls to modify the look. So the next thing that's cool, though, that I would also like to show you is that right now all of my particles on the lattice have a goal weight in here of 0.25. Something that you can do is each lattice point or particle can have its own goal weight. So if you're trying to create a tree, like in a forest, for example, where the tops of the trees have more wind movement than the ones at the bottom, which is pretty normal when you have a bunch of trees packed together, you can actually create that effect. And so to do that, I would actually put the goal weight to a value of 1. And when I do that, and I hit play, we don't get any movement at all, because now all of these particles are locked onto the shape of the original lattice, which is copied and hidden here. But what I can then do is take these particles and change their goal weight one by one. And to do that, you go to Component Mode in Maya, and under the first button, right-click, go to Particles, and you can now actually select the individual particles that are on this lattice. So if you want, you could even hide deformers, which is there, so that you only see the particles that are associated with that lattice. So if I go in the front view, and here, I could take these lattice points, or rather these particles, and say the ones at the top I want to have a goal weight of 0.25, while the ones at the bottom have a goal weight of 1, for example. And the way you edit goal PP on a per particle basis is to go to the attribute spreadsheet, and then inside here, or rather, sorry, the component editor, because we're editing components, go to particles, and for the selected particles, you will see goal PP. So whenever a particle object has a goal weight added to it, which was the case when we turned this into a soft body, every particle gets its own goal PP value, which is multiplied by the goal weight value that's here. So you have a goal weight value for the whole particle object and a goal weight value for each individual particle object. So if I put the goal weight to 1 for the whole object, I can then go and select the particles on the bottom and say, well, those have a goal weight of 1, and then these could have a goal weight of 0.8, and these could be 0.5, and these could be 0.4, and these could be 0.25. So basically, my particles on the bottom have a higher goal weight, and the goal weight just starts to lower as we go higher and higher up the tree. So if I now were to go back to my render view and rewind and hit play, what we'll see is that, and let's also get our deformer visible again, rewind to frame 1. So the particles that are at the bottom are not moving, while the ones at the top are. And so to make this a little bit more obvious, I would now need to maybe make my turbulence field a little bit stronger. And it looks like there's some particles that I didn't select that I thought I did. No big deal. So particle object. So goal weight is at 1. Select particles. So I'm going to grab all those particles at the top. I didn't actually select all the particles because I did it from an orthographic view, and clipping planes kept that from working. So I'm going to go back to the component editor and then go to goal PP. So you can see that on my top row of particles, some of them are set to 0.25, but a bunch of them are still at 1. So 0.25 for all of those. Grab that row. I want all of these to be at 0.4. Grab this row. All of those at 0.5. And all of these at 0.8. And then the ones at the bottom are all at 1. All right, so now when I hit play, what you will notice is that the particles on the top are moving a lot more with the turbulence than the ones on the bottom. And so let's grab our turbulence field. So it's kind of cool to be able to make these kind of controls. And so this is something that you really wouldn't be able to do with PaintFX or with Onyx either, really, to have height-based turbulence. And so here I can go to my turbulence field. Obviously, if I put the turbulence to 10, then the effect is going to kind of go away, and these particles are just going to still move a little bit and eventually just come to rest at their initial state, or rather at their goal. So that's kind of the last attribute I would want to point out, is on your particles there's an attribute called conserve, which stands for conserve momentum. And so that means that your particles don't have any dampening on them. They just, if they get pushed, they'll continue wanting to move in that direction as if they're in a vacuum. So that's why even when I hit play and I turned off the turbulence field or lowered the magnitude to 10, these were still moving quite a bit because they're fully conserving momentum. So if I put that to 0.9, or let's say 0.95, that means that they will lose energy every frame. So now if I hit play and go to my turbulence field, let's put the magnitude really high. Let's put it to 500. So when I hit play, I can see the effect of the turbulence field. But if I put the magnitude on the turbulence field to 0, you'll see that those particles come to rest. It takes them a few frames because my conserve is set to 0.95. But the point is that they do come to rest. So magnitude 500 on my turbulence, hit play, and then I'm going to quickly turn the turbulence field off, and the particles just then slowly come to rest. So the reason I'm showing you this is that if you wanted to animate wind, wind getting stronger and weaker, you could just animate the turbulence field magnitude and know that your leaves are going to behave accordingly. So if you've never done soft bodies and you've never done particles and dynamics and all this stuff, you're probably going to have to watch this chapter like 10 times to get it. Hopefully not, and hopefully I explained it clearly. But that's pretty much how you do soft body lattices. So I think it's pretty cool. So put the magnitude back to 500. And we've got that effect. And if I want the particles down here to be moving a little bit more than they are, so I can always just go and adjust the goal PP in the component editor for those lower particles. So if I go and reopen this scene, so just so we can take a look at how I had things set up in here, let's go and I can definitely just get rid of all the instance stuff. So visibility off. And so if I go to show deformers, so it's on, but I've hidden all of my deformers. So if I get them all visible, you'll see that I just have a whole bunch of lattices in here. And so let's just go to other perspective view. And we can also take a look at where those lattices are. So you can see that I put lattices on the leaves. And if you're wondering, what the membership is of any of these lattices, if I grab a lattice and I want to know what it's affecting, I can just go under animation mode, edit deformers, edit membership. And it'll show me all of the vertices that are inside that deformer. So I can see all of the vertices of the leaves, but not the branches, are inside that lattice. So the only difference to what we did is that these lattices are just a little bit heavier. So you can see that I have the divisions set to 10, 10, and 10 on these lattices. So that just gives me a little bit more control and a little bit nicer turbulence inside the leaves. So if my divisions were only set to, let's say, 3, 3, and 3, it would really make it look like this whole big blob is moving underwater. So the higher your divisions, the tighter the detail is that you're going to get in the behavior. And so obviously I could go and put the divisions up to 50, 50, 50, but that's going to slow performance down a little bit and give you a lot more points to have to worry about when it comes to setting goal weight and goal PP. So once you start having that many points and you want to have a nice smooth effect or relationship between them, then it starts to get a little bit more complicated, where I would probably start using things like springs, which is something specific to soft bodies, springs. But that's really unnecessary for trees. So that's why I think, there's definitely scenarios where we could get more advanced and complex and start getting into that. But for the purposes of this demonstration, I don't think that's needed. So if I go inside here and rewind to frame 1 and I hit play, then you can see that all of these lattices are just starting to move. But of course, for playback reasons, there's no reason for them to be visible. You can take all of your lattices and hide them, and they're still going to affect your geometry. And so if I go inside here, I can see that all of these leaves are still moving as a result of dynamics. And then also in my scene, I only have one turbulence field. So all of these lattices with all of their particles are all connected to the same turbulence field. And so as you connect or create more lattices and turn them into soft bodies, you can just use the window settings preferences, or rather relationship editors, dynamic relationships. You can select your particle object. So, for example, the particle object on one of these lattices, and it'll show you all the fields in your scene. So if I go inside here, I can see that the particle object for each of these lattices is connected to turbulence field 1. So they're all connected to the same turbulence field. So you don't have to do it that way. It's just easier to have one turbulence field connecting or controlling all of your trees. And so that's pretty much that. And so if I go and jump to this, I know that just with the frame rate that you're probably seeing, you might not be getting a great frame rate when I play this back. But basically, once you have a camera move like we have in this shot, then you have to think, what's the focal point of the shot? Are people really going to be staring at the leaves, or are they going to be staring at this little dude that's standing right there? Chances are, if somebody watches this, they're pretty quickly going to key in on that dude and the horizon being so bright. And so just subconsciously, they'll notice that there's movement in the leaves, but they're not going to be sitting and staring at the individual leaves. And so that's where this effect, I think, works out pretty well. So, and if we just focus on the last few frames, you can, definitely notice the movement in the leaves, and it looks pretty cool. So, and it saves you having to export 1 billion OBJs from Onyx, right? Because each one of these trees, like that one's only 34,000 polys, this one's 100,000, this one's 300,000. So I have a 150 frame sequence. So if you do the math, if you have 1, 2, 3, 4, 5, 6, 7, 8 trees, then 8 times 150, you're talking about 1,200, OBJs that have to be exported from Onyx, imported into Maya, and then all of that stuff needs to be cached in the scene for all of the blend shapes, and your scene file will get really big. So sometimes you have no choice and you have to do that. But I think that for a scene like this, it's just good to be aware that you don't have to worry about it. And then the last thing that I'll point out is that all of this works with the instancer. So if you are using the particle instancer like I have in this scene, let me turn it back on. If you instanced onto particles, and let's just go back to frame 1, and let's just get that to be visible. All right, but let me hide all the lattices. All right, so my instancer node, all of the animation that's on these trees via the lattice is on these as well. So when you take a geometry that's animated and you instance it onto particles, the particle instance copies will see the animation on the original tree. You can still randomize the rotation, randomize the scale, and still get the animation. So in the QuickTime I just showed you, that's what we were seeing. So each one of these trees has animation on it. Specifically, if I go to the leaves, I can see that if I select the leaves on that tree, it has an FFD node, freeform deformation, which is a lattice. And then that object right there is what's on my instancer node. So if I go to the attribute for the editor for the instancer, I can see all of the trees that are on the instancer node, and they all are animating as well. So yeah, so you can animate a single tree however you want, shape animation, blend shape, instancer, whatever, or lattices, dynamics, soft bodies, turbulence, and the instancer will respect it, which is really, really cool. So that tree that we imported as an OBJ earlier, we could also instance copy that onto particles, no problem, and it would work. But we'll do more instancing and stuff like that later on as we get further into the DVD. But for now, that's pretty much this tip that I wanted to show you, is how to create soft body wind animation in the leaves of your trees. And it's something that I think is kind of cool. So the reality is that, if we were in a live classroom setting, I'd probably have to demonstrate this like 3 or 4 times just to get it to stick. So, but I really just recommend watching the chapter a couple times if you haven't done soft bodies before. It is really pretty easy, and it's really, really fun to get into. So there you go. So now that we've talked about how to export animation from Onyx, and we've talked about how to do animation with lattices, now we're going to move on and start exploring the broadleaf library with Onyx a little further. And so let's move on to that.